So just now we saw how to actually find the statically determined system. Now, find out the question remains: what is the objective of how to design a truss? The one thing that says that how to first of all find the forces in the members, which are called the internal forces. So there are two different techniques that exist now to find the forces members of any truss. So technique number one is method of joint, and technique number two is method of section. In method of joint, generally is applied at the joints, and method of section, it is to find used to find internal forces in the selected members. Okay. So in the method of joints, generally when a truss system is less, the number of members are less. If you have to find out the forces in all the members, then this is when the truss size is big, when you have to find the forces in selected members, then what is required is you can use the method. What do you really do with method of section? In method of joint, summation of fx is equal to 0, summation of fy equal to 0 at all the joints. Okay. In method of section, we have three equations: summation of fx is equal to 0, summation of fy is equal to 0, and when you want about the selected point, have on it. Okay, so this one is useful for a small. This one is used for truss with small number of members, and this one is used for truss with large number of members. So it is not specific, but more or less this is how people apply it. So let's look at the method of joint and then method of section, how it is applied in some selected point. So example for method of joint. So let's say you have been given truss given by P, one is given as yes. One is given as C. First give the point A, B, and C. This is your truss, and you will have to find the internal forces in this member, and this member, in all the members. So how you are going to do? This is the method of joint. You will have to find equilibrium equation for all these points. So first of all, find the reaction. Whenever you are applying either this or method of section, first thing that now when you draw the free body diagram of this particular body, what will happen? You will be P, right? Here you are having two reactions. Find that this will be like this. So let us take RAX, RAY, one as RX. Okay. So the number of, first of all, the number of reactions over here are 3. R is 3. Number of members are n, which is 3. Number of equations you can write is, number of equations that you can write is times number of joint. So number of joint is given by 3, 2 into 3, which is given by 6, right? So if you try to see this m plus r, which is nothing but 3 plus 3 is equal to 6, which is equal to, which is 6. Hence it is solvable problem and statically determined system, and it is also a simple truss. So after this you should be very happy. And then what you have to really do is you have to find out these components. So first of all, when I told you that you can write down the equation of motion, only two equation of motion at the joints. So this is valid when you try to draw the FBD at the joint. When you have to take the whole system, you have to take and summation of moment equals to 0 at any. So first of all, to find first thing after this, step number 1. Now the step number 2 says find the reaction. So here you can use this, you can use this, and you can use R. So remember that these three equations can be applied to the whole body, but when you are writing the equilibrium at the joint, it's just 2. So for example, if you take summation of Fy equals to 0, this will give you Ray positive plus 0, so Ray equals to 0. If you take moment about, let us say C, A, and this is your B, moment about, this one will give you clockwise, which is times this particular, you can see that distance from this to this is A plus C. So this is and the moment of the moment sorry okay, I'm sorry, we have to, since we are taking momentum of A times A, okay, because this P times C, not P times A, this will be because this distance is C, and this one is the clockwise direction, so it is positive, and this one will be RCX into, so this one is negative, RCX, RCX. Now this one is used, this one is used, summation of fx is equal to 0, what you are going to get is your RCX plus E minus RAY equals to 0. RCX is nothing but PC by A. RAY minus PC by A. So your reactions are, RCX is given by MC by A. RAX is given by P minus A by, or this A minus, and R divide is 0. So you now know, now you can specify, you can write down the equilibrium equation at these joints to find out the forces in members. But how to do that? To do that, what you can do is try to, all this distance. So let's try to find the forces in that. Step number 3. Step 3. Let us write down, here we have two components which are unknown. So let us start with joint number. FBD of joint C. That here you are having, the force of this direction, that, let us assume direction is FCA. The force F, and this one is your RCX, which is EC by A. So first thing that you have to do, there are f of fx is equal to 0 and f of fx is equal to 0. Now what is known here, this you know about, right? So it means that you should know what is this angle. So let us call this angle as theta. And what will be this theta? This theta, tan theta is equals to nothing but, now this particular distance is given by, A plus C divided by B. So this is what it will be, cos theta. So it means that your equilibrium equation along x will be nothing but, if it is a theta, this will be FCB cos theta plus RCX equals to 0. But if you one, FCB. What is your cos theta? Cos theta based on this formula will be this divided by this. It means that this will be your B divided by your A plus C whole square cos theta and plus RCX. What is RCX? It is nothing but P by A is equal to 0. Means that your FCB by A and remember this. It means that the force direction which we assume will not be in this direction, but that will be. And how we consider the tension? Let us say something is compressed, the tension forces will act inward. If something is expanded and extended, the tension forces will act inward. If something is compressed like this, it will try to come out, so the internal forces will come out. So it means that when you reverse the direction of this particular guide based on this one, this member will be under compression, right? Right. So you have found the forces in this. Now there is, when you use summation of Fy equals to 0, on what will happen? You will be having, since now its direction is reversed, so first of all let it be like this for right now. So you have FCA plus FCB sine theta equals to 0, and FCA will be given by. Okay, so sine theta over here is nothing but this divided by this. It means that this particular quantity is minus FCB, so plus BC by sine theta. Sine theta is nothing but your A plus C divided by plus. So you will see that this will get cancelled, and what you will be getting as FCA is FCA will be FCA will be this will be plus C by. So force in this member is given by this one. So but the way we consider this, it means that it is trying to come out, and the direction of this force is inside. It means that this is under tension. Okay, component is under tension. Similarly, now you can find out the forces in this direction. So to find the force in this direction, what you will be doing? A BD of joint A. If you take, so what are the forces? Again, forces over here are, I will just write somewhere here so that, let me first write the forces. So FCB is PC A plus C whole square FCB is equal to minus. Similarly, you can find out your A plus B divided by, right? Now our forces at joint, so joint A. So the FBD over here will be, have, let's say, the force here which is FAB, right? Since this one is under tension, so here the force will be in this direction. This is one, and this force is 0. RAY was 0. Then you have RAX which was acting in this direction. RAX which was given by A minus C BC A plus B divided by the, so here again you can use summation of fx is equal to 0 and summation one of that. So first of all you have to, let us call this as phi, and this phi is and what is this particular distance? This particular distance is C, and this particular distance is B. But your C by B. Okay? So phi will be given by C by B. F summation of fx equals to 0, which is nothing but cos phi RAX, and this one will give you FAB is nothing but your FAB is not known, and cos phi will be what? Cos phi will be your B divided by square plus B square, okay? And RAX, and RAX is given by P. Okay? So it means that this gives you FAB divided by, okay? This is your component in this particular member, and this solves the problem for fine. So since it is coming under this direction, this will be under tension. So this is under tension, this is under tension. This is how we apply method of joint to find out. Okay. How now next is, let me also say, now let me explain the method of section. The method of section. In a given problem, first of all, in the same problem we take, we want to find out the member, let's say P is given, first let us say you have to find out the forces this and this member. You don't really require to find force in this member. This way, just to get a problem clearer, what we will do is we will take a section which is called A, B, C. and this section is x and x dash. So in this particular member, we will draw the FBD of this section. Important advantage of using method of section is that you don't really require to find the reaction. So find reaction forces over here. So how to really find out? So let us assume that the forces in this member is now question is how to like find the forces BC. So you have to use summation of Fx is equal to 0 in this case, summation of Fy equals to 0, and summation of M equals to 0. When you are having this kind of case, it becomes, so let us say if you're, we know that what are these angles. So if you take these angles, let us take this as gamma or alpha, and this one as beta, this is your alpha. So in this case, this is your alpha and this is your beta, and obviously your tan alpha will be given by Py plus C, and beta will be given by. So this way you can write down what is the x component over here. So first of all, this will be P minus FPA sine beta FBC equals to 0. Similarly, Fy can be written as FBA cos beta minus FBC. From here you will see so from here you can find out one in terms of other. So here FBA is given by FBA is your beta, right? So afterwards, when you substitute this particular so summation of FB minus plus FBC cos alpha cos beta and minus FBC FBC is equal to sine alpha cos beta cos alpha sine beta, and we will have cos beta on the upper side. So this is what will give you FBC. So basically, if you try to find out all this quantity, so have something like times. So you can substitute the values of what will be the cos beta value. Cos beta is your this by this. It means that this square by b square, right? Sine beta is equal to going to b by And similarly, you can write down cos alpha. So cos your alpha, not beta. Alpha, because we are taking this small angle as the alpha, and this beta will be nothing but your, let's say, cos is c divided by c square plus square, and sine beta is equals to b by quantities you will be getting. However, you also know FBA is nothing but this. Just multiply this particular uh, minus p cos beta will get minus cos alpha, and this is how you can apply the method of section numbers which are given. Means that you will have to take section of both. And the third equation you can use to just verify whether the results that you have obtained is correct or not. And rather than this is also some problem while so how you are going to apply this third equation. To apply the third equation, what you can do, moment about somewhere here. If you take moment about this, and this obviously will be y component about this, and you can verify that this. Yes, we are done with the method of joints as well as method.